Okay, so we're going to look at the trapezoidal rule. So the trapezoidal rule is used when you're trying to find the area of an irregular shape. So like if you think of finding the area of a lake is really irregular. So if you look at the first diagram there, the trapezoidal rule will actually help you to find that, an approximate area of that shape. Or if you think of a field, again, like if I ask you to find the area of a field, unless it's rectangular or square or triangular, it's going to be quite difficult to do. And as you know, so many fields aren't them regular shapes. They generally tend to be quite irregular. So the formula you're going to use is called the trapezoidal rule. And this formula is in your log tables, but the formula is actually quite tricky to understand. Like if you look at that formula, it's difficult to make heads or tails of it unless you familiarise yourself with it and tried loads of questions on it. So the first thing I'm going to do is I'm going to break down the formula first. So like the area is equal to h over 2 times y1 plus yn plus 2 times y2 plus y3 plus y4 plus whatever else is there plus yn to the minus 1. So it is quite difficult, but when we break it down, and if you learn it as we break it down, you will understand it an awful lot more. So what it is our area is equal to h over 2. So if you just look at this diagram up here, see the way h comes all the time. The h actually represents the width. So we're going to call it width over 2. That width will always be constant, okay? Because when you are finding the area of the trapezoidal rule, they've actually broken up the area of the shape into like equal boundaries. So this is your width. This is broken into equal parts. So your width will always be consistent. What y1 represents is, if you look at the diagram here, I just highlight that, sorry. Y1 represents your first height, and then plus yn, so you can see from the diagram, yn represents your last height. So we have our width over 2 bracket our first height plus our last height plus, then we have 2 and a bracket. So y2 plus y3 plus y4. Again, you can see these all in here. y2, y3, this would be y4, this would be y5, 6, 7, 8, 9, and so on. Okay, so basically what that means, if you look at that purple highlighter there, it's all the heights, but not the first and the last. So what we call it is the sum of all the other heights, because sum means adding up. Sum of all the other heights. And that's our formula broken down for us, so it's simplified. So I'll just go over it again. So your h represents your boundary being cut off, so it's actually your width. So your width over 2 multiplied by your first height plus your last height plus 2 times all the other heights added. We'll just close it off. Okay, so I've just inserted a kind of tidier version of it there now. So your area of your irregular shape is your width over 2 times your first height plus last height plus 2 times the sum of all the other heights. So we'll try this in an example. So if we just go down here, we have an example. So we'll try find the area of this irregular shape. So finding the area of an irregular shape, we know that we're using the trapezoidal rule. So first thing we do, like in all area and volume, is we write in the formula. So what I'm going to do is I'm going to write in the simpler formula. So you can write in the formula from your log tables, but just ensure you understand that the h means width and then the y1 means first height and so on. So we'll try to do it together. So the width over 2. So the width of this shape that I have here, as I said, the width will always be consistent. It'll always be the same. So if you look here, okay, 3, 3, 3, 3, 3, 3. So that's obviously my width. It's what the boundaries have been split into. So my width is going to be 3, then over 2, big bracket. My first height, so if I look at my first height, is this part here. That's 9. Plus my last height. So I look here, it says that's 5. Perfect. So I've used 9 and 5. So if you want to get rid of them, just because we know for the last part it's the sum of all the other heights, so you have to ensure you don't use 9 and 5 again, that 9 and that 5. Plus 2 times the sum of all the other heights. So I'm going to add 9 plus 8 plus 7 plus 6 and plus 5. Close my bracket. So I'll have 3 over 2. And here, make sure we don't do, like, we use our BOMDAS, okay? So do what's in your brackets first. Okay. So we'll have, and the reason I'm saying this is just be really careful. You can add 9 plus 5. Alright, that'll give you 14. But you can't add 2 to that, because if you can see, the 2 is actually multiplying by these. So we say 9 plus 5 plus 2 on what's in that bracket. So 17, 24, 35 when you add all the bits in the bracket. So we'll have 3 over 2 bracket. So 9 plus 5 gives us 14 plus 2 times 35. Be so careful there. So that'll be 3 over 2 on 14 plus 70. So that will be 3 over 2 on 84. And 3 over 2 on 84 will give us 126 meters squared. And that is how you find the area of that irregular shape. Just to do one more example of this, we look at the shape here. So again, it's an irregular shape. In this book that I'm just taking these examples for, they call the width the base step. So they're telling us in the question that the width was 3. Okay, so again, I have my formula up, and I rather do my simplified formula, but again, just copy it from your log tables, but just ensure you understand it this way. So you can, if this is on the exam paper, tilt the exam paper so it looks kind of like the baseline is flat, or the width line is flat in front of you. As you can see with the example I have here, there's a top part and there's a bottom part. Okay, so that's really important, because we have to add in both shapes, and you'll see on the sheet that I gave you out, you'll read about this as well. So our width, so as I said, it told us in the question that our base height was 3, so we're going to start with 3 over 2. First height. So if we look, so I'm kind of tilting a little bit. This is our first height here, and as you can see from it, the height is actually 0. Like if we look at the second height, it's 4 plus 6, whereas here it's just 0. If a trapezoidal rule ends like on this, that's going to be 0, whereas if it ended something like this, that's not going to be 0. Okay, so my first height is 0, plus, let's look at my last height, so that's this one here. Again, that's ended closed, so that's 0, plus 2 times the sum of all my other heights. And as I just said to you, if I wrote 4 as my first, or the sum of my other heights, so my first height of the remaining heights, that would be wrong, because that line actually isn't 4, it's actually 10, because you have to take into account the bottom part that's underneath it. So like, think of an iceberg, the 4 is only shown, but there's 6 underneath it. So we'll go 10 plus second ones is 10 again, 5 and 5,